Okay, moving on with our gas laws. Our next one is Charles's law. And Charles's law is for Jacques Charles, who investigated the effect of temperature on the volume of a gas, this time with a constant pressure. So with each experiment, he found that as the temperature increased, the volume was increasing, and as the temperature decreased, the volume also decreased. So temperature and volume can only be measured over a limited range. At some point when you change the as you're changing the volume or you're changing the temperature, the substance is going to change states of matter. So this is only going to work for a gas over a certain range. At low temperatures, your gases are going to condense and form liquids. So again, we have this limited range. When Charles graphed volume versus temperature at constant pressure, he wound up with straight lines. And he extrapolated those lines to zero volume and found that they all intersected at the exact same point, which is down here, and is absolute zero. So you can see our red dotted line here. This would be at STP. So at STP, our volume is going to cross the line at 22.4 liters, and we are at 1 atmosphere. So that's why we use our standard when we're doing volume conversions. So these dotted lines, this is the extrapolated part. Remember we said that below a certain temperature, gases are going to condense or freeze. So you're not going to have a gas anymore, you'll have a liquid or a solid. So he had to estimate what was going to happen at this point. So he took the slope of the curve that was already occurring and kept going with it and found that all of these gases cross the temperature line at the exact same point, which is negative 273 degrees Celsius, or we know it as 0 Kelvin. And that is because Lord Kelvin realized how important this value was and identified it as absolute zero. This is the temperature at which the average kinetic energy of the particles would theoretically be zero. So kinetic is moving, so the moving energy of the particles is going to be zero. That means the particles are going to stop, theoretically. Charles's law states that the volume of a fixed mass of gas is directly proportional to its Kelvin temperature. So for these gas law problems, we need our temperature in the Kelvin unit. This is only if the pressure is kept constant. In a direct relationship, the ratio of the two quantities that change is going to be a constant, so we can set them equal to each other. And that's going to give us V1 over T1 equals V2 over T2. And that is Charles's law equation. You can rearrange it so that you get proportions and to make it easier to rearrange. So in that case, you're going to kind of do your cross multiplication, and you're going to get V1 times T2 equals V2 times T1. And you are certainly welcome to use that if you need to solve for one of the T's. If you're solving for one of the V's, it's just easier to move the T out of the way. So V is going to be for volume. Your volume units have to be the same. T is for temperature. Temperature has to be in Kelvin for this equation. Again, 1 are your initial measurements and 2 are your final measurements. So we have a balloon inflated in a room at 24 degrees Celsius to a volume of 4 liters. The balloon is then heated to a temperature of 58 degrees Celsius. They want to know what is the new volume if the pressure remains constant. Since we're dealing with temperature in a gas law problem, the first thing we're going to have to do is turn those temperatures into Kelvin. So 24 plus 273 is going to give us 297 Kelvin. And 58 plus 273 is going to give us 331 Kelvin. Now, just because we converted that does not mean that's what we're going to go with. For our sig figs, you're going to have to go with the least number. I kept 3, so our answer is going to have to be in 3. So we have 297 Kelvin. Kelvin is a unit of temperature. And we have 4.00 liters. Liters is a unit of volume. Since this is what we're starting with and they're asking for the new volume. These are going to be our T1 and our V1. So the balloon is heated to 58 degrees Celsius, which we found to be 331 Kelvin. So that's going to be our T2. So we are looking for V2. So now that we have identified our variables, we can write our original equation. V1 over T1 equals V2 over T2. And we are solving for V2 here. So that means we need to move T2. So to get T2 out of the way, multiply both sides by T2. Now we can plug in and solve. So T2 is 331 Kelvin. And we're going to multiply that by V1, which is 4.00 liters, divided by T1, which is 297 Kelvin. So our Kelvin units cancel. We're left with liters, which is what we're looking for because they ask for volume. So 331 times 4 divided by 297 gives us 4.46 liters, and that is going to be our answer.